Okay, so my name is Bilal, and today we'll be solving additional mathematics session Feb March year 2022, paper 2 and variant 22, which is of 2 hours. Now, before we move on with question 1, there is an announcement that please do like, share, and subscribe our channel. So question 1 is given as a line L has equation 4x plus 5y equals to 9. Points A and B have coordinates negative 6, comma 7, 1, comma 9 respectively. Find the equation of the line parallel to L which passes through the midpoint of AB. So there is a line which has an equation 4x plus 5y. Points A and B have coordinates this. Find the equation of line parallel to L. So it has to be the same gradient as L and which passes through the midpoint of AB. So let's first calculate the midpoint of AB. Midpoint of AB can be calculated by adding both x and adding both y and dividing by 2. So this would be midpoint of AB would be negative 6 plus 1 over 2 and 7 plus 9, that is this 9 and this 7 over 2. So we get our answer as negative 2.5. This is for negative 5 and then divided by 2 is negative 2.5. This is 16 and upon 2 is 8. So this is our midpoint. Now it has to be parallel to L, which means the gradient is equal to L. So we'll be rearranging the equation to find out the gradient. So this would be 4x would go on the right hand side. This would be 5y is equals to 9 minus 4x. 5 would be divided, so this would be negative 4x over 5 plus 9 over 5. So this is our basically gradient. So let's write down the equation. Our equation would be negative 4 over 5x plus c. We can plug in these values, or we can simply use the y minus y1 is equals to m into x minus x1's formula. So this would be y minus 8, then negative 4 over 5 x negative, and negative 2.5 will be positive 2.5. This 5 will be multiplied and then 4 will be multiplied, so you'll get our answer as 5y negative 40 equals to negative 4x and negative 10. This would go over there and this would come over here. So this would be 5y plus 4x equals to 30 as our final answer. Now moving on, we have solved the equation this. So let's solve this. We'll be using the quotient law, which will merge these two logs. So this would be log 5 8x plus 7, since it's negative, so this 2x would be divided and this would be 2. So we'll solve this. This would be 5 power 2 is equals to this. So this would be 25 equals to 8x plus 7 over 2x. This is simple logs. When we go from logs to the exponential equation, this is what we are doing. So next we multiply it by this, so we get our final x. This would be 50x minus 8x equals to 7. So this would be x as 7 over 42. 7 over 42 can be written as x equals to 1 over 6. So this is our final answer. Now moving on to question 3, we have a group of students. 4 girls and 3 boys stand in a line. Find the number of different ways the students can stand in a line if there are no restrictions. No restrictions means 7 factorial simply. So this is basically 5040. Find the number of different ways the students can stand in the line if the 3 boys are next to each other. If the 3 boys are next to each other, which means these boys are next to each other, the other 4 places are left. One can be here, one can be here, one can be here. All the 3 boys can be here and all the 3 boys can be here. And these 3 boys can be arranged as well. So this will be 3 multiplied by 5 factorial. 3 factorial multiplied by 5 factorial. So we get our answer as 720 basically. This is our answer. Moving on to part C, we have Cam and Dia are 2 of the girls. Find the number of ways the students can attend if Cam and Dia are not next to each other. So if they have to be next to each other, we can calculate when they are next to each other. So there is Cam and Dia, which are next to each other. We are left with other 5 places. These can be arranged by 2 factorial. They can be here, they can be here, they can be here, they can be here, or here, or here. So we have 6 places. So this would be 6 factorial, and these two can be rearranged as well. So this would be 2 factorial. We get it as 1440 when these two are together. So to calculate when they are not together, we can simply subtract it from the no restriction parts. So this would be simply 3600. So this is our final answer. Now moving on to question 4. We have find the x coordinates of the points of intersection of the curve this and y is equals to this, giving your answer to 3 decimal places. So he needs the answer in 3 decimal places. So let's just first take the LCM. This would be 36. This would be multiplied by 9, and this would be multiplied by 4. So we get our answer as 9x squared plus 4y squared over 36 equals to 1, and our second equation is y is equals to 3 upon 2x. So this can be written as 9x square plus 4y square. This 36 would be multiplied. This would be 36. Now we can substitute our y. So this would be 9x squared plus 4 multiplied by 3 over 2x whole squared equals to 36. So we square it, so we can cancel this. So this would be 9x squared plus 3 squared is 9 over x squared equals to 36. We can multiply the whole equation by x square. So we get the answer as 9x power 4 negative 36x square plus 9 equals to 0. We can divide the whole equation by 9. So we get our answer as x powered 4 negative 4x square plus 1. We can apply the quadratic formula or use our calculator. Since there is no restriction of calculator, we can use our calculator to get our answer of x square. This would be 2 plus minus root 3, or to write it simply, this would be 3.732 or 0.268. We can under root both the answers, so we will get our answer as x equals to plus minus 1.932 and x equals to plus minus 0.518. This would be 2 plus root 3 and 2 minus root 3, and then this would be under rooted to get our answers as positive and negative. So this is our final answer. Now moving on, we have our question 5, A part, where we are given this graph. The diagram shows the graph of y is equals to f of x modulus, where f of x is a quadratic function. Write down the two possible expression for f of x. Now we have two roots as 1 and 4 and one another point. So there are two roots. We can write this as x equals to 1 and x equals to 4, or we can write it as x minus 1 multiplied by x minus 4. It can be our f of x, but let's just calculate this. If it is 4, so we can substitute x as 0, so we get it as negative 1 and negative 4. So our answer matches simply. So it can be either positive or negative x minus 1, x minus 4 as our f of x, since the modulus is already applied. It can be negative or it can be positive. So this is our final answer. Now moving on, we have the three roots of p of x equals to 0, p of x equals to this, x equals to this, x equals to n, x equals to n plus 1, where a and b are positive integers, n is a negative integer. Find p of x, simplifying your coefficients. So we have x equals to 1 over 5, sorry, x equals to n, x equals to n plus 1, and n has to be greater than lesser than 0, sorry, that is written, n is a negative number. So let's just simplify it. So this would be 5x minus 1, this would be x minus n, this would be x minus n plus 1. So we can multiply all of them. So this would be 5x minus 1 x minus n, x minus n plus 1 equals to 5x squared plus ax squared plus bx minus 2. Now we can simply calculate this by multiplying each and everything. So this negative 1 would be multiplied by negative n to get a constant. So this would be negative 1 multiplied by negative n, and then these two would be multiplied by negative n plus 1, and this would give us our answer as negative 2. So this negative and negative would be positive, and this negative and negative is cancelled out. So we get our answer as n into n plus 1 equals to 2, and then we get our answer as n squared plus n minus 2 equals to 0. We solve this and we get our n as minus 2. We get our positive answer as well. So our positive answer was 1, and this would be rejected since n was lesser than 0 previously. Now moving on, we have x equals to, I'm writing this again, x equals to 1 over 5, x equals to negative 2, and then x equals to negative 1. So we can multiply it by fx minus 5x minus 1, x plus 2, then x plus 1. Then we can compare it simply, plus bx minus 2. Our ax square would be simply 5x into x square. This would be this we can simply multiply these two to get our answer as x squared plus 2x, and plus x would be 3x, and 2 multiplied by 1 is 2. Then we can multiply 5x minus 1, then compare it. So this 5x would be multiplied by 3x to give us 15x squared, and this negative 1 and x squared can be multiplied to give us negative x squared, and this can be compared with ax squared. So this is 14x squared is equals to ax squared. So we have our a as 14. Similarly, we can do it for b. So this would be negative 1 can be multiplied by 3x, so this would be negative 3x, and 2 can be multiplied by 5x, so this would be plus 10x equals to b of x bx. This would be 7x equals to bx. Our b would be simply 7. So we have our n, we have our a, and we have our b. Moving on to question 6, a part 1, using the binomial theorem, expand this in ascending powers of x as far as the term in x cube. So it needs the terms in x cube. It's a pretty simple question. This is our first term, and our next term would be 7c1, that is 7, 1 powered 6. Let's not write it again, but this would be a lot simpler here. I won't write it again and again. So because 1 powered anything is 1. So this would be 3x powered 1. Then next would be 7c2 and 3x powered 2. Then 7c3, 3x powered 3. I think this is enough because this will make us x powered cube. So we get our answer as 1 plus 21x. 7 multiplied by 3 is 21. 7c2 and 3 squared, that is 9, is multiplied, so we get our answer as 189. And then 7c3 and 3 cubed, that is 27, is multiplied, so we get our answer as 945 x cubed. So this is our final answer. Now moving on, we have shown that your expansion from part 1 gives the value of 1.03 powered 7 as 1.23 to two decimal places. So we have to use 1.03 as this part. So this would be 1 plus 3x equals to 1.03. This one would be subtracted and 3 would be divided. So this would be 0.03 divided by 3. Our x is 0.01. We can substitute x as 0.01 over here in this equation. So we get our final answer as 1 into 21 plus 21 into 0.01. plus 189 0.01 squared plus 945 0.01 whole cube, and then we solve it to get our answer as exactly 1.23. Now in part B we have find the term independent of x in terms of this. Now we can simply go forward with x powered 4 upon 2 powered 15 and then simply go on. But let's just think of it in a different way. Like if it has a power of 4, then this power needs to be lesser, which means we have to at least go more than half. Now let's calculate it from 10. So this would be 15c10. This power would be x powered 4 and 2. This power would be 15 minus 10, that is 5, and 2 over x powered would be 10. So if we compare it, this would be 20 and this would be 10. So this wouldn't be an independent power. Let's move two more. Let's calculate the 12th one. So this would be 15c12 x powered 4 2. This would be 15 minus 12 is 3, and then 2 over x, and this powered would be 12. So this would be 12 and this would be 12. We can easily calculate it. 15c12 x, this is 2 cubed, so this would be divided by 8 and then 2 power 12. This, so we get our final answer as 232960. So this is our final answer. Now moving on to question 7, we have our question 7 as, in this question all the angles are in radians. This is a similar uh, type of question. Solve the equation sec square theta is equals to tan theta plus 3. We can use an identity over here. The identity is basically 1 plus tan square theta is equals to sec square theta. Using this identity, we can substitute it. So this would be 1 plus tan square theta equal to tan theta plus 3. We'll bring each and everything to the left hand side. This would be tan squared theta, negative tan theta, negative 2 equals to 0. Now we can solve this, or we can use our calculator. Let's solve as this would be tan theta, negative 2 tan theta, and positive tan theta would be our roots. Taking tan theta as common, this would be tan theta plus 1, negative 2 as common, tan theta plus 1 equals to 0. We get our tan theta as negative 1 and tan theta as 2. So if we calculate our theta from here, this would be negative pi by 4 and this would be 3 pi by 4. Since tan theta is negative in the second quadrant and the fourth quadrant only, so if we have to calculate from this fourth quadrant, since we have limited range, so this would be negative pi by 4, that is our alpha, that is pi by 4. And this would be our third quadrant, since it has pi by 4, and this pi by 4 will be subtracted from pi to get our 3 pi by 4. Now let's solve this. We get our theta as, let's calculate it directly. So we'll get our final answers as this would be in second and third quadrant. So this would be 1.11, and the other alpha would be, the alpha which was calculated would be subtracted from, would be added in the negative pi. So this would be negative 2.03 as our answer. Now moving on, we have our part B as show that for, let's just erase it a little bit. Yes, show that phi lies in between 0 and pi by 2 when this is solved. So tan theta, tan phi can be written as sin phi over cos phi, which is divided by 1 minus cos phi can be written as sin squared phi, since it's an identity. So this would be sin squared phi under root, and this would be cancelled out. This will go in the denominator and this sign would be cancelled out again with this. So this would be 1 over cos phi, which is basically equals to sec phi. Now moving on, we have our part C given that cosec x equals to negative 17 over 8, and it lies between 3 pi by 2 and 2 pi, which is in fourth quadrant. Find the exact value of cot x. Now let's first rearrange it to get our answers. So this would be 1 over sin x is given as negative 17 over 8, and actually our sin x is given as negative 8 over 17. Let's just draw a triangle on fourth quadrant. So this would look something like this. This is our negative 8 and this is our 17. We can use the Pythagoras theorem. This would be 17 squared negative 8 squared, and this would be rooted, so this would be 15. So we have our answer as 15. Now this needs the exact value of cot x. So that is basically sin x upon, cos x upon sin x. Cot x can be written as cos x over sin x. Our cos x is basically 15 over 17, and our sin x is negative 8 over 17. The 17 and 17 is cancelled out. We get our answer as negative 15 over 8 basically. Moving on to question 8. We have the diagram shows the sector AOB of a circle. This AOB, center O and radius 15 centimeter is given. Angle AOB is pi by 6. This, and point C lies on OB such that CB is A and AC is a straight line. All the things are given. Find the exact value of A such that the area of the triangle is equal to the area of the shaded region. Now let's write it down what is given. Area of triangle can be calculated by using 1 upon 2 A, B, sine C. So we have 1 over 2. We have our A as 15, and this is our OCR as our B. So this is 15 minus A, and our sine C is basically sine pi by 6. And we have area of shaded region. Area of shaded region can be calculated by using the area of sector and then subtracting this area of triangle. So when we are subtracting area of triangle from this whole sector, so area of shaded region, let's write it first. Shaded region is area of sector minus area of triangle, right? So this area of shaded region and area of triangle are equal. Now let's think about it. Let's just substitute this area of triangle over here. So this would be area of triangle again. We have this area of triangle again. So this can be substituted over here, and this could be area of triangle multiplied by 2, and this can be written as area of sector. So we have our equation as 2 into area of triangle is equals to area of sector. Now let's remove it let's just calculate it. So we have to multiply the area of triangle by 2 and then equate it to area of sector. Area of sector is given as 1 upon 2, 15 squared, and then pi by 6. So this 2 and 2 are cancelled out, and then we solve it. This 15 and 15 is cancelled out. We get our answers as 15 pi by 12 equals to 15 minus A sine pi by 6. Let's rearrange it to get our A. Our A would be 15. This A would go over there, and other than this, each and everything would go over here. First of all, this sine pi by 6 would be divided, and then this A would be going over there. So that we can write our final answer as 15 minus 15 pi by 12. sine pi by 6, and finally we can write it as a is equals to 15 minus 5 pi by 2. This is our final answer. Moving on to part B, we have for the value of a found in part A, find the perimeter of the shaded region, giving your answer correct to one decimal place. So we have to calculate the perimeter. Let's just go back. So what is the perimeter? Perimeter of the shaded region. So we need this arc, this, and then this. We don't have this. We can calculate this, and we have this. We need to calculate this by using cosine rule. So let's just first calculate that using cosine rule. So this would be root 15 squared, and this was 15 minus 5 pi by 2, and this altogether is 15. So this would be 15 minus 15 minus 5 pi by 2, positive 5 by 2. So this would be cancelled out. So this would be 5 pi by 2 basically. So this is 5 pi by 2 whole squared. We are using this triangle. We have this length, and then this angle. And then 2 multiplied by 15 multiplied by 5 pi by 2, then cos pi by 6. And then we'll add all the other things, that is AB arc. AB arc can be calculated as r theta. Our r is 15 and our theta is pi by 6. This is basically our A, that is 15 minus 5 pi by 2. Let's just add other things. This would be 15 and multiplied by pi by 6, and adding our A, that is 15 minus 5 pi by 2. Now when we solve this, we get our answer as 24.1. Moving on, we have our question 9. A, as a vehicle travels along a straight horizontal road at time t is equals to 0. The vehicle traveling at a velocity of w meters per second passes point O. The vehicle travels at this constant velocity for 12 seconds. It is at the constant velocity for 12 seconds. Let's just first draw a graph. So it's moving at w for 12 seconds. Just prolong it. All right. It then slows down with a constant deceleration. There is a constant deceleration for 10 seconds. So this would be 22 until it reaches a velocity of w minus 14. So this would reach it here. Let's just assume it. So this is basically w minus 14. And then it continues to travel at this constant velocity for 28 seconds until it reaches the point 458 meters from O. So then there is a constant velocity, then it reaches to 50. So we have three shapes basically, right? We can just simply take this whole rectangle and then this trapezium. Let's just take it as A and this as B. So our distance is 458, and velocity times area under the line gives us distance. So this is our rectangle. This is w minus 14 multiplied by 50, and then this trapezium, which has similar sides as 12 and 22, and the height as w minus 14. So this is basically 14. So we have our this is the sum of two sides, and then this is 12. This is 7. Then we can calculate it. 50W minus this would be 700, I guess. Um, yes, this would be 700. Then we can go on to solve this. So this would be 7 12s are 96. Sorry, 12 6 are 72. Then this is 84. And then 22 sevens are 7 to the 14. 7 to the 14. 154. This is 154 basically. So we have 458 over here. We'll add these and then move to there. So we'll get our answers as 150, then 80 is 230, 230, 238, 238, and then minus 700 is basically 62, and 562. 562 would be added over here. This would be 50W, and we get our answer as 920. I guess I made some mistake somewhere. I guess I made some mistake over somewhat. Where did I make a mistake? This is this, this is this, this is all right. So it's 458. We get our 50W. All right. Then we get it as negative 462. It has to be 462. Sorry. So this would be 920. This would be 50W. And then this would be cancelled out. We get our W as 18.4. Sorry for the long delay. We have our W as 18.4. Moving on to part B, we have a particle moves in a straight line. The velocity v meters per second of the particle at time t seconds, where t is greater than 0 is given by this. Find the value of t for which the acceleration of the particle is 0. We need to calculate the differentiation first to get our acceleration. So we have our dv upon dt as our acceleration. Let's first expand it to get our answer. This would be t squared. This would be minus 5t and minus 4t. This would be negative 90 and plus 20 as our final. So this can be differentiated. This would be 2t minus 9, and it has to be acceleration as 0. So we'll be using this as 0. So this would be, we'll get our t as 9 over 2 or 4.5. Moving on, we have find the set of values of t for which the velocity of the particle is negative. For the velocity of the particle to be negative, it has all the t, it is t minus 4 and then t minus 5. So 4 and 5 are the critical values. In between those values, it could be negative because it is basically a happy phase curve, since the t squared, a of t squared is basically positive, greater than 0, which means we have a minimum curve. So we have all our negative values in between these values. So this would be 4 till 5. We have all the negative values. Moving on to part 3, we have find the distance traveled by the particle in the first 5 seconds of its motion. So for the distance, we need to integrate it. So this would be 4 till 0 because 4 is a critical point, and then we will be using 5 and 4 separately because it is a critical point. And this would be, I guess, modulus, because this would be in negative since we have already calculated it. So we get our answer, we get our integration as t cubed, power positive, and then power in the denominator, then power positive and would be added by 1, and then this power would be in the denominator 20t, and then for 0 positive Similar thing over here, but limits we have as 5 and 4. So we have our upper limit over here. If we apply the upper limit, this would be 64 over 3 negative 72 plus 80. Now if we apply the lower limit, this would be 0. Here if we apply the upper limit, this would be 125 over 3 negative 225 over 3 225 over 2, then positive 100, and then this would be subtracted by 64 over 3 negative 72 and positive 80. So what is basically happening is this and this is cancelling and this is cancelling and this is cancelling. So we have our final answers as this, and we can write it simply as 29.5. Moving on to question 10, we have the relative to an origin. The position vector of P is this, the position vector of Q is this. The point R is such that PQ is equals to 5PR. Find the unit vector in the direction OR. So it needs a unit vector in the direction OR. So let's just calculate OR first. PQ is equals to 5PR. PQ can be written as OQ minus OP, and PR can be written as OR minus OP. This is multiplied by 5 basically. So we have our OQ as 8I plus 13J. This is subtracted by this is subtracted by OP, that is 3I. Negative 2J equals to 5. OR has to be calculated. Negative, our OP is simply 3I negative 2J. Here we get our answer as 5. 8 minus 3 is 5I. 13 plus 2 is 15J. And then we have 5 OR negative 3I positive 2J. Divide this 5 by 5. Divide this 5 by this equation. So this would be I plus 3J equals to OR negative 3I plus 2J. This whole would go over there to get our final OR as 4I plus J. Our OR is this. Now we need to calculate the unit vectors. For that we need the modulus. So this would be 4 squared plus 1 squared. This would be root 17 simply. And we can write OR as the unit vector. OR's unit vector as, first we'll give the direction, then the magnitude, then the denominator. So this is our unit vector finally. In part B, the position vector of S relative to O is lambda j, given that RS is parallel to PQ. For it to be parallel to PQ, there has to be something multiplied by this. So this would be RS can be written as OS minus OR. We have our OR. OS is simply lambda j, and this is negative 4I plus j. Let's just rearrange it. So we have our negative 4I and negative j as common. So this would be 1 minus lambda. And our PQ is basically 5I plus 15j. So to make it 5I plus 15j, we have to first multiply it by negative, and then it has to, for it to be 5, we have to multiply it by 5 upon 4 to cancel this 4 and then multiply it by 5. So this negative 5 over 4 is multiplied by this as well. So this would be negative 5 over 4, 1 minus lambda equals to this j, this is 15. So we get our answer as this 4 would be multiplied over there. This would be negative 5, positive 5 lambda. This would be 60. This would go over there. So I made some mistake, I guess. So this is 60, then negative 5 is basically divided. 4 is multiplied and negative 5 is divided. So this would be 15 into 4 is 60, and then 5 is divided. This would be 12, 1 minus lambda, and then we get our answer as finally. I think I made some mistake over here again. This would be positive 5 by 4, 5 over 4, I guess. And this would be positive. This 12 would go over there. So this would be 1 minus 12, which is negative 11 as our lambda. We get our lambda is negative 11. So why this would be 5 over plus positive 5 over 4, since this negative 5 over 4 is multiplied by the I and j. It is a necessary. So this won't have an effect on this. So we have our lambda is negative 11. Now moving on, we have our question 11. The diagram shows part of the graph this, and x equals to 2, the line x equals to 2 meets a curve at point this, and the line AB is parallel to x-axis. Find the area of the shaded region. Now we need the area of the shaded region over here. So let's first calculate what we'll be getting when our x is 2 and our y value. So this would be, or do we need it? Let's just calculate it. So we get our b as 6 plus e powered 4 into 2 minus 5. So this would be 6 plus e cubed. So our b is basically 2, 6 plus e cubed. So we have y is equals to 2. Sorry, we have y as 6 plus e cubed, and we have y as 6 plus e powered 4x minus 5, since this is a constant line. So what we need to do is, if we calculate the area under the line, we get this, and if we remove this area under the curve, let's just use another pen, colored pen. If we remove this area, we get the area we want, that is this, right? So we need to just calculate the area of we need to calculate the area of line, and then we need to subtract the area of the curve. So our area of line would be simply this, with the limits to 0, and our curve's area would be simply this by integrating both. So we get our answers as 6 plus e cubed. This would be multiplied by x. We'll be applying limits 2 and 0 over here. This would be subtract. Now let's just integrate it as well. So this would be 6x, negative 6x, plus e powered 4x minus 5 over 4, and then we apply the limits of 2 and 0, and then we subtract it. So we get our answers as, when we apply the limits, we get it as 2 multiplied by 6 plus e cubed, and when we apply 0, we get nothing, so this would be empty. Then we get our answer here as 6 multiplied by 2 is 12. Then this would be e cubed over 4. Then this is 0. This would be 0, and then this here would be negative e powered negative 5 over 4. This would be negative, since it's a what we call it, the lower limit is applied over here. So let's just solve this. We get this 2 into 6 is 12, and then this 12 is subtracted, so this would be cancelled out. So this would be 2e powered cube. This negative would be multiplied, so this would be negative 2e cubed, and then this e cubed upon 4. So 2e cubed and this e cubed upon 4. So this would be 8e cubed, then minus e cubed, this would be 7 upon 4 p cubed. Then I guess what we can do is this would be 7 over 4 e cubed. This is cancelled out, this is cancelled, and then this is left. So this would be 1 over 4. This can go down, so this would be e powered 5. So we have our final answer as this. Area of the shaded region was. We can calculate it as well, but we can leave it here as well. So since this is an exact answer. Now moving on, this is a pretty difficult question. So it is a similarity question basically. The diagram shows a right triangular prism of height h inside a right pyramid. The pyramid has a height of 12. Pyramid has a height of 12. And base is an equilateral triangle. Base is an equilateral triangle. This ACB is equilateral triangle. So, and this is basically 8. So this is 8 and this is 8 as well. The base of the prism sits on the base of the pyramid. So this is residing on the base of the pyramid. Point PQR lie on the edges of OA, OB and OC respectively of the pyramid OABC. Pyramids OABC and OPQR are similar. This similarity is already written. Show that the volume of the triangle can be given as this. So let's just take PQ. PQ is similar to AB, right? Since it is given as similar. PQ over AB, that is 8. We can take the ratios of the sides. And the other ratio we can take is this 12 and 12 minus h. This has a height of 12 minus h, and this whole has a 12 height. So this would be 12 minus h. Since we have taken PQ, so we need to calculate this height. So this would be 12 minus h, and this height is basically 12. So we have our PQ as 8 multiplied by 12 minus h over 12. We have our PQ here, right? Thankfully we have some space here. Now, since it's an equilateral triangle, this is an equilateral triangle, the area of PQR can be calculated easily. Area of PQR can be calculated 1 over 2 AB sine C, and this is basically 60, and this A and B is this PQ. This can be squared basically. So this can be written as 1 over 2 8 12 minus h, and then 12, this is whole squared. This can be cancelled out, this can be written as 2, and this can be 3, and this 2 squared can be cancelled out. This would be 9, and then this is sine pi by 3, right? And then for volume we need to multiply it by h. Since the volume of prism can be written as volume of prism is 1 over 2 base area into height. So we have our base area over here, which can be written as 2, and then 12 minus h whole squared is 144 minus 24h plus h squared over 9, and then sine pi by 3 is basically root 3 upon 2. This is multiplied by h. This 2 and 2 is cancelled out, so we get our final answer as root 3 over 9, and then this is multiplied by h. So this would be h cubed negative 24h square plus 144h. So this is our final answer. Now it is given that as h varies, v has a maximum volume, find the value of h that gives the maximum value of v. For maximum value of v, we need to calculate the differentiation and then equate it to 0. We have our v as root 3 over 9 h cubed negative 24h square plus 144h. We need to calculate the differentiation of this. Let's just take root 3 over 9 as common. Then we can differentiate it 3h square. This would be negative 48h, then 144. It needs to be equated to 0. This would be going there, and then this would be divided, so this would be simply 0. So we get our answer as 3h square negative 48h plus 144. We can divide the whole equation by 3. So we get our h. So we get it h squared negative 16h plus 48. We can use the calculator over here. So we get our answers as h is equals to 12 and h is equals to 4. Now h is equals to 12 would be rejected. Why? Because this altogether is 12 and h can't be 12. Alright? So h is equals to 4 is accepted only. This was it from my side. Thank you for watching, and please do like, share and subscribe. Thank you.